It glows. It floats. It passes through windows and walls, explodes without warning, and leaves behind the scent of ozone and sulfur. For centuries, people around the world have witnessed mysterious spheres of fire drifting through the air, but science is only beginning to understand what they truly are. This is the baffling story of ball lightning, part folklore, part physics, and still one of nature's most enduring enigmas. Welcome to our baffling world, exploring the unknown one mystery at a time. Like, subscribe and share your thoughts. We'd love to hear your perspective. Thank you. Ball lightning, rare and mysterious glowing orbs that often occur during thunderstorms, has been seen for centuries. One of the earliest convincing records comes from medieval England in 1195, where the monk Gervase of Canterbury described a sighting near London. On the 7th of the Ides of June, around the 6th hour, a marvellous sign descended near London. For the densest and darkest cloud appeared in the air, growing strongly with the sun shining brightly all around. In the middle of this, growing from an uncovered opening, like the opening of a mill, I know not what was the white colour that ran out. That, growing into a spherical shape under the black cloud, remained suspended between the Thames and the lodgings of the Bishop of Norwich. From there, a sort of fiery globe threw itself down into the river. With a spinning motion, it dropped time and again below the walls of the previously mentioned bishop's household. This account, newly identified in a 12th century chronicle, predates what was previously thought to be the earliest English report, the Great Thunderstorm at Widdicombe in the Moor in 1638. During that thunderstorm, witnesses saw an 8-foot ball of fire crash through the church, smashing pews and windows and filling it with a foul sulphurous odor. The fiery sphere split into two and exited, leaving 4 people dead and many injured, a disaster locals at the time blamed on the devil or God's wrath. Such supernatural interpretations were common in earlier eras before science offered alternative explanations. By the 18th century, ball lightning had entered scientific discussion as a real phenomenon, sometimes called globular lightning or Kugelblitz. A famous lethal encounter was recorded in 1753. Georg Wilhelm Richmann, a physicist in St. Petersburg, was attempting Benjamin Franklin's kite experiment when a ball of lightning appeared. The glowing orb traveled down his apparatus and struck his forehead, killing him on the spot. The explosion blew open his shoes, singed his clothes, and even tore the door off its hinges. This dramatic event, a scientist killed in front of a witness, convinced many that ball lightning was a genuine natural occurrence, albeit a dangerous one. Around the same period, seafarers also reported fireballs during storms. In 1726, the crew of the sloop Catherine and Mary wrote of a large ball of fire falling from the sky, splitting their mast and killing a man. Likewise, in 1749, Admiral Chambers aboard the HMS Montague saw a blue ball of fire approach the ship and explode as great as if 100 cannons had been discharged, shattering the mast and knocking men to the deck. These early reports often noted a strong sulphurous smell left behind, a detail repeated in many later accounts. Through the 1800s, scientists and scholars collected such stories and attempted to categorize the phenomenon. The French scientist François Arago gave ball lightning its name, foudre globulaire, globular lightning, in 1837 and published a compendium of reports. Anecdotes from that era show the classic features of ball lightning. For instance, in 1841, a reddish-yellow sphere was seen rolling through the streets of Milan during a storm. An artist, Lorenzo Buti, watched it rise to a church tower cross and explode with a crash. He was so astonished that he wrote to Arago about it. In an 1852 case in Paris, a glowing ball emerged from a fireplace and drifted around the room in front of terrified witnesses, then shot back up the chimney, blowing the chimney top apart. Numerous reports describe these orbs entering buildings. One entered an Indian temple in 1877 and exited calmly out a side door, observed by multiple people. In another remarkable event, in 1894, residents of Golden, Colorado, saw multiple balls of fire playing tag for over 30 minutes around an engineering building, a spectacular display noted in the local newspaper. And in 1901, a dazzlingly brilliant ball of fire descended in the town of Uralsk, then in the Russian Empire, crashed through a house full of people, wreaked havoc in one room, then blew out through a wall, destroying a stove on its way. This incident was serious enough to be reported in the Bulletin of the French Astronomical Society. Such reports from around the world, Europe, India, North America, Russia, and others, gave ball lightning a global notoriety by the early 20th century. Prominent figures also witnessed ball lightning, adding credibility to the tales. Tsar Nicholas II of Russia, for example, recalled seeing a fiery ball during a church service as a child in the 1880s. In his memoirs, he described a sudden thunderclap and a fiery ball flying in through a window and whirling around the floor near him and his grandfather, Emperor Alexander II. The orb then flew out the door, leaving the young prince astonished, though his grandfather remained calmly composed, crossing himself during the incident. The famous British occultist Aleister Crowley also gave a detailed description of a ball lightning encounter in 1916. He saw a dazzling globe of electric fire hovering inside a cottage during a thunderstorm. It exploded with a sharp report, giving him a slight shock in the hand. Such first-hand narratives, often by educated observers, gradually shifted ball lightning from myth into a subject of scientific interest. By the late 19th century, it was being discussed in scientific literature. For example, in 1875, the French writer Wilfrid de Fonvielle noted 150 known cases and described how a ball entered a house in Corrèze, France, killing a pig in a stable, to the perplexity of the witnesses. Scientists like William Snow Harris in England began theorizing about it by the 1840s, and more systematic compilations appeared in the early 20th century. The March 15, 1930 edition of Nature magazine contains the account of a globular lightning case reported by William Colebrook Reynolds that took place in July 1921 in Grindelwald, Switzerland. About 5 p.m. of a hot fine July afternoon in 1921, I was in the dining room of the hotel with my sister Margaret and 6 other guests. A dark cloud was noticed approaching from the east, but neither rain, hail, nor snow fell before the occurrence of the fireballs, and only distant lightning had been observed. Suddenly, from the air inlet of the large stove, in which a small wood fire was burning, came practically simultaneously a large number of very bright round balls of various colors, the largest perhaps nearly as large as my head. Almost at the same moment, a dreadful deafening explosion occurred, and the balls had all vanished. The room was full of a grey smoke, perhaps disturbed dust, and a strong peculiar odor was observed. I opened the doors to clear the air and then examined the room. I could find no signs of scorching on the curtains, flowers, or the unenclosed stuffed birds and animals in the room. The fire had not been disturbed and none of the fuel was ejected. The guests who were nearest the stove momentarily experienced a slight electric shock, but no one was injured. Walter Brand's 1923 German monograph Der Kugelblitz gathered numerous cases up to that time. Still, most evidence remained anecdotal, earning ball lightning a reputation as one of nature's unsolved mysteries in atmospheric electricity. Some skeptics even questioned if it was real or just an optical illusion, since reproducing it or recording it instrumentally was nearly impossible before modern technology. Nonetheless, as of the mid-20th century, thousands of sightings had been documented, numerous well-attested cases worldwide, a variety of sometimes terrifying descriptions, and a long trail of attempted interpretations, from demons and spirits in earlier centuries to nascent scientific hypotheses in the 19th and early 20th centuries. Yet, it remained an elusive, almost legendary phenomenon, awaiting definitive explanation. During World War II, reports of strange Foo Fighters hinted that ball lightning might not be just a ground-level curiosity, but also an aerial one. Allied night pilots in 1944 described glowing orbs pacing their aircraft, bright orange lights that flew alongside and even outmaneuvered them. These Foo Fighters did not appear on radar and left pilots scared shitless, as one airman put it. Military investigators at the time considered explanations ranging from St. Elmo's fire to enemy secret weapons. Some modern historians have speculated that at least some Foo Fighters could have been ball lightning or a similar atmospheric electrical phenomenon following the planes. On August 12, 1956, in Tamborsk, Russia, an Il-12 commercial airliner had a frightening experience with ball lightning. While flying through a cold front containing dense thunderclouds, with an air temperature of about -3 degrees Celsius, the crew saw a rapidly approaching dark red, almost orange fireball, 25 to 30 centimeters in diameter, to the front and left of the aircraft. According to the report, at a distance of not more than 30 to 40 centimeters in front of the nose, the ball swerved and collided with the blade of the left propeller, exploded in a blinding white flash, and left a flaming tail along the left side of the fuselage. The sound of the explosion was loud enough to be heard over the noise of the engine. No substantial damage could be found. One of the left propeller blades had a small fused area 4 centimeters along the blade and less than 1 centimeter in depth. Around the damaged region was a small area of soot, which was easily wiped off. Indeed, ball lightning inside aircraft would become a recurrent theme in later decades. For example, in March 1963, the astronomer Dr. Roger Clifton Jennison was flying on an airliner through a thunderstorm when the plane was struck by lightning. Moments later, he and other passengers were astonished as a glowing sphere 20 centimeters in diameter emerged from the cockpit and drifted calmly down the aisle of the plane. Jennison reported his experience in an article he published in the journal Nature in 1969. His credible, detailed report made headlines and is considered a classic modern account of ball lightning. It proved that even within the enclosed metal fuselage of an aircraft, a ball lightning event could manifest, a fact which theories must account for. Pilots and crew have since reported similar encounters occasionally. In one dramatic case on a Loganair flight in 2014, ball lightning appeared in the cabin just as lightning struck the aircraft's nose, and the plane temporarily lost control, dropping steeply before recovering. All on board were unharmed, but the incident shows the continued relevance of this phenomenon to aviation safety. From the 1950s onward, scientists and other professionals increasingly came forward with first-hand observations, adding weight to the evidence. In 1951, a German physicist named Hans Doležálik witnessed a bright ball descend during a storm in Tübingen. It exploded with a loud bang, leaving a 50-centimeter scorch mark on the ground and even damaging nearby power line insulators. The local power station recorded a fault at that exact time, correlating with the event. In another case from 1955, Dr. Leopold Breitenecke, a coroner in Austria, was performing an autopsy during a thunderstorm when lightning struck the building's electrical meter. A blue-white ball of light then emerged from the hole in the wall where the meter had been, the size of a fist, and floated 5 centimeters above the floor. It glided out the door, bounced down exterior steps, and vanished into a graveyard, all in about 5 seconds. Amazingly, Breitenecke would see a second ball lightning years later in 1975 from a distance, suggesting some people have luck or misfortune enough to encounter it twice. These reports by scientifically trained observers often noted precise details, sizes, colors, motions, and effects on surroundings, helping build a more quantitative picture. Several Soviet and Western scientists not only observed ball lightning but attempted to collect data from it. In 1965, Russian chemist S. Dmitriev saw a bluish ball lightning drift above some river rafts and then collide with trees. Quick thinking, he grabbed evacuated test bulbs and managed to sample the residual smoke trail left by the orb. Laboratory analysis of the captured air revealed elevated ozone and nitrogen dioxide levels, 50 to 100 times higher than normal air. This was one of the first chemical pieces of evidence associated with ball lightning and confirmed that the phenomenon can produce chemical byproducts consistent with ionized air or plasma, ozone as a sharp odor often noted by witnesses. In a 1967 incident in Latvia, engineer A. Mikkelson experienced a ball lightning literally emerging from his radio. During a storm with distant lightning, a white-blue sphere about 20 centimeters wide popped out of the metal front panel of his battery-powered radio set. It hovered above his hand for a few seconds, then snapped loudly and vanished. The man's left arm, which had been closest to the ball, went numb and became partially paralyzed for several minutes, with small burn marks appearing on the skin. Upon investigation, 2 electrical fuses in the house were found blown, though the radio was not mains powered and remained intact. Neighbors reported a loud thunderclap at that time, suggesting a lightning stroke had occurred nearby, possibly triggering the ball. This case is remarkable for the physical effects on a person and electrical systems, and it was documented via correspondence with researchers. Other well-documented post-war cases include a 1968 sighting in Oxfordshire, England by Eric Dunford, a space scientist who, with 2 others, saw an intense glowing sphere, perhaps 4 to 8 meters across, appear after a close lightning strike. It shone bright enough to illuminate fields and had a tail of light or smoke, hovered for 5 seconds, then faded slowly. The following case from June 8, 1974, that took place in Wallsend-upon-Tyne, was reported by Philip Bagnall, Network Director of the British Meteor Society, and has details that make it as strange as many UFO reports. At 1:36, I awoke to find the room bathed in a dim light. I was lying on my left-hand side at the time. I wiped the sleep from my eyes and rolled onto my back, and at the bottom of my bed, only about 60 centimeters from the window, also on my left, and some 1.6 meters off the floor, floated a most magnificent orange sphere. I automatically started counting the seconds, but at the same time broke out into a cold sweat. After all, the last thing one expects to find when one wakes up is a miniature sun. The ball was slowly floating from the window towards the center of the room, and it wasn't until it was about a meter from the window that I realized what the object was. I got out of bed, looking at my watch as I did so, and moved parallel with the ball. At approximately 2.5 meters from the window, the ball stopped. From the time of first seeing the ball to the time it stopped moving, some 20 seconds had elapsed. The ball was still about 1.6 meters off the floor, and it just seemed to hang in space. The time was 1 hour, 36 minutes, 47 seconds according to my watch, although because of circumstances I didn't really trust the mechanism. I was about a meter from the ball, and I noticed that it was revolving, say, once every 10 seconds. It was limb darkened, the center emitting a light on a level of about 25 to 30 watts. By this time I had stopped counting. I could not feel any heat, and nor could I hear any noise, only the rain on the window. I reached out to touch the ball, and it was only when my hand was about 10 centimeters from the apparent limb did I feel any heat. Even then it was not very great. In the end, I decided not to touch it. Instead, I dropped my hands to see if that would have any effect on it. Needless to say, it didn't. Quite frankly, I had no idea what to do. It was only after several seconds of watching it did I try to estimate its diameter, about 15 centimeters. For no apparent reason, I was under the impression that it was watching me as closely as I was watching it. After what seemed like hours, the ball finally decided to float upwards toward the ceiling at about the same velocity as it had crossed the room, and it then moved straight through the ceiling in a manner typical to that of many a Hollywood ghost. I looked at my watch again. The time was 1 hour, 37 minutes, 15 seconds. This was just before the ball had reached the ceiling, so that by the time the ball had completely vanished, I suppose the time was 1 hour, 37 minutes, 18 seconds. Total duration of the observation, 51 seconds. The exiting ball left no marks upon the ceiling. In July 1978, an Austrian meteorologist, Wolf-Dietrich Wagner, observed an orange-yellow elliptical fireball skimming the surface of a lake in the state of Carinthia after a lightning hit the water. It moved slowly over the lake before exploding, lighting up half the lake in a sodium-like yellow glow. The same year, also in Austria, in the region of Vorarlberg, a man named Werner Burger was taking some time exposure photos when he heard a peculiar sound like a Christmas sparkler or wire brush moved over an edge intermittently. Just ahead of him, a fireball fell down, surprising Burger and leading him to release the wire used to control the camera's long exposure. When asked to revisit the course of events, he estimated that his observation lasted for 2 or 3 seconds. The fiery object seemed to drop in free fall. The resulting photograph was computer-enhanced and revealed strange sparks and flares accompanying the core of the ball. Publicity following the photographed event brought to light 17 additional ball lightning anecdotes associated with the incident. In August 1982, staff at the Cavendish Physics Laboratory in Cambridge witnessed ball lightning during a violent storm. A brilliant blue-white ball was seen moving across the ground outside, and one even entered through an open window. A lab assistant described a bright, spinning, pyrotechnic-like object that came in, bounced off a photocopier, and then flew out again, startling everyone. Having multiple trained observers in one of the world's top physics labs suddenly confronted by a roaming fireball underscores how unpredictable and real the phenomenon can be. Another interesting case happened on September 10, 1989 in Ashford, in Kent, England. Ray Cahill was making an amateur video of lightning strikes from the bedroom of his home when he captured the image of a luminous sphere that appeared to be ball lightning. The ball appeared immediately after a lightning flash and a crash of thunder. The dull red ball entered the camera's field of view at the left, moved diagonally across the screen and exited at the top right.
It was during a thunderstorm on the 9th of September that Ray Cahill filmed the ball lightning from his bedroom window at Ashford. Now, scientists are confirming that it's probably the first real film footage of ball lightning ever shot. It's a very rare phenomenon, and rarer still that the person seeing it actually knew what it was.
They're taken as UFOs, as antimatter, as all sorts of wonderful things, and also what it really is, that is ball lightning.
What actually is ball lightning?
Well, again, opinions differ, but the most likely explanation at the moment is that it's a ball of radio frequency energy. That's ordinary wireless waves, if you like, tied up in a ball. And curiously enough, if you have enough energy in those wireless waves, then you can make it shine just like a ball.
And why is Professor Jennison so certain that this is the real thing?
Look at this center here, this dark patch, which gradually rotates. It precesses as the ball spins round and moves across the screen. Now, anybody producing an artifact of ball lightning, trying to fool the audience if you wish, or otherwise anything which happened accidentally, it's very, very unlikely to look like that, with that precessing pole on it.
And the man who captured the ball lightning with a Super VHS camera is still in a bit of a spin. What do you plan to do with this film now that you have it?
Well, to be absolutely honest, I'm not quite sure. It's happened so quick, and suddenly the interest has come into it, and I have no idea what I should do with it yet.
The film, which we're showing you slowed down, will in fact probably be studied by scientists worldwide. Shyam Abhivaga, Coast to Coast.
The event lasted about 1.5 seconds, and video analysis led by Dr. Roger Jennison and colleagues suggested it was ball lightning. They described a toroidal form with a dark inner core, mottled depth, and eightfold symmetry. Controlled tests indicated the object measured around 20 centimeters across and moved at about 1 meter per second. On this basis, they concluded it was probably ball lightning, perhaps in an early stage. Their conclusion was disputed by Stuart Campbell, a leading critic of ball lightning claims. After examining the site and the camera, he argued the image was an artifact caused by car headlights reflecting on the stop plane out of focus. Campbell replicated the effect and published comparison photographs in The Skeptic magazine. A ball lightning case with rather spectacular side effects was observed and carefully reported by Mrs. P. Stafford, looking through her front window in Conwy, Wales on August 12, 1992. She saw a ball of white fire, larger than a football, some 20 to 30 feet from her, traveling horizontally at a constant height up her drive. The weather was rainy, with some hail but no lightning or thunder. The ball was round, opaque and predominantly white with some yellow and surrounded by a blue iridescent halo. The witness described it as being reminiscent of a comet, and its light was like that from a fluorescent tube. It appeared to be rotating or spinning and was clearly visible in daylight for 10 to 15 seconds. It hit an oak tree in a neighboring front garden with a terrific crack and explosion, becoming smaller. It split the bark and trunk, showering splinters of wood over a distance of about 50 yards. While doing so, it rolled down the tree and dispersed in flashes. Mrs. Stafford said that there seemed to be waves of lightning passing from it into the ground and radial sparks streaming out of it in all directions. In 2012, a major breakthrough in instrumental observation occurred in China. Researchers at Northwest Normal University in Lanzhou were monitoring a thunderstorm with high-speed cameras and spectrographs when, by pure chance, they recorded a ball lightning event from creation to dispersal. A glowing orb about 5 meters wide formed just after a cloud-to-ground lightning strike, then floated horizontally for 10 meters before vanishing. Crucially, the spectrometer captured the light spectrum emitted by the ball. The analysis showed emission lines corresponding to silicon, iron, and calcium, elements abundant in the local soil. This provided strong evidence for the idea that when lightning hits the ground, it can vaporize materials and somehow create a luminous, persistent ball of hot ionized gas containing those vaporized elements. The Chinese team's results, published in 2014, were the first recorded optical spectrum of natural ball lightning. This landmark observation not only proved that the phenomenon emits light characteristic of certain materials, but it also supported specific theories, as we'll see in Part 3. In summary, the modern era, post-World War II to today, has transformed ball lightning research from purely anecdotal into a semi-observational science. We now have multiple cases investigated with scientific rigor, eyewitness reports by pilots, physicists, engineers, often with corroborating physical evidence, scorch marks, electrical disruptions, and chemical residues, for instance. Ball lightning has been seen entering aircraft, homes, laboratories, and open fields, displaying sizes from a few centimeters to several meters and colors across the spectrum. Its behavior is consistently bizarre, floating through closed windows, moving against the wind, silently gliding or explosively detonating. But unlike in past centuries, we have begun to catch a few of these great balls of fire with cameras and sensors. These contemporary cases with hard evidence are extremely important, because they allow scientists to test hypotheses against observations. And indeed, armed with better data, scientists in recent decades have formulated a number of plausible theories for what ball lightning really is. The final section will explore the main characteristics of this phenomenon and the scientific theories, from chemical reactions to quantum physics, and assess which ideas are currently considered the most likely explanations for this enduring enigma. The witness reports mentioned in the previous two parts are just a small selection from the much larger body of sightings of the phenomenon known as ball lightning. From this extensive collection, researchers have identified a set of recurring characteristics, features that appear time and again across independent accounts from around the world. While no two encounters are exactly alike, the following list summarizes the most consistent and distinctive traits attributed to ball lightning. In terms of appearance and shape, it is typically spherical or pear-shaped, with fuzzy or glowing edges. It is occasionally irregular, a hollow center is sometimes reported. In terms of size, it ranges from 1 to 100 centimeters in diameter. Most commonly 10 to 40 centimeters, and in average 20 to 30 centimeters. Regarding color, it is most often red, orange, or yellow. Less commonly white, blue, or blue-white, especially in harmful cases. It is rarely green, violet, black, or colorless. In terms of brightness, it is comparable to a domestic lamp. It's clearly visible in daylight. Some appear dim, others blindingly bright. Concerning sound, it may be silent or emit hissing, buzzing, crackling, or fluttering sounds. With respect to smell and after effects, it's often followed by a sharp or pungent odor like ozone, sulfur, or nitrogen oxides. It is sometimes accompanied by colored mist, brown in transmitted light or blue in reflected. In terms of duration, it typically lasts 3 to 5 seconds and can range from under 1 second to over a minute, exceptionally up to 15 minutes. Brightness tends to remain constant. Concerning motion, it moves horizontally or vertically at a few meters per second, often 2 meters per second. It may hover, bounce, remain stationary, or travel against the wind. Erratic or rotational motion is sometimes observed. In terms of entry and exit behavior, it often appears after cloud-to-ground lightning or from cloud base. It may enter buildings through chimneys, open windows, cracks, or doors. It frequently circles a room and exits through the same or new path. Regarding disappearance, it may vanish silently with a pop or in a violent explosion. It's sometimes accompanied by flashes or triggered by contact with conductors. Regarding heat and thermal effects, it is often void of any sensation of heat, especially with floating types. Attached types, especially white and blue, can generate intense heat, cause burns, ignite objects, and even be fatal. With respect to behavior near conductors, floating balls tend to avoid conductors and humans. Attached balls move along wires, gutters, and metallic surfaces, often resting on high points. As to multiplicity and splitting, sometimes multiple balls appear. A large one may split into smaller ones. Rare cases show beaded chains or stacked formations. Concerning aircraft and enclosed spaces, ball lightning has been observed entering and leaving metal aircraft without causing damage. It can form or appear inside enclosed spaces. As far as electromagnetic effects, it can disrupt electronics, radios, and magnetometers. It may leave behind magnetized or scorched materials. Finally, in terms of risk and impact, some are harmless, others cause damage, burns, or fatalities. Interaction depends on contact and proximity to conductors. Explaining ball lightning has proven to be as challenging as catching it. Over the years, hundreds of hypotheses have been proposed, reflecting the phenomenon's complex nature. Even by 1855, Arago noted it was an unexplained luminous meteor, and scientists since then have offered ideas ranging from mundane to wildly exotic. To this day, no single theory has achieved consensus, but a few leading contenders have strong support. We'll now make an overview of the main scientific theories about ball lightning and how they attempt to account for its remarkable properties. One of the most supported explanations is that ball lightning is essentially a burning cloud of nanoparticle dust formed when a lightning strike vaporizes soil or other ground materials. In 2000, John Abramson and James Dinnis showed that a strike on silica-rich ground could create a plume of pure silicon vapor, which then condenses into fluffy silicon nanoparticles that rapidly oxidize in air. This oxidization, essentially the silicon rapidly burning, would release energy as a glowing ball of hot plasma, which could persist for a few seconds as the silicon is consumed. The theory elegantly explains why soil ingredients like silica, iron and calcium have been detected in actual ball lightning spectra. It also accounts for common witness details, hissing sounds from chemical burning, sparks, bits of hot material flying off, and that pungent ozone or sulfurous smell, byproducts of oxidized air and burning impurities. In 2007, a team of Brazilian scientists conducted an experiment to test the Abramson-Dinnis theory of ball lightning. To simulate this, the researchers applied low-voltage electrical arcs to pure silicon wafers in ambient conditions, producing glowing spheres with physical properties similar to naturally reported ball lightning. The resulting luminous balls exhibited behavior strikingly similar to natural observations: lifetimes up to 8 seconds, erratic motion, rotation, ability to squeeze through narrow gaps, and the capacity to burn objects on contact. While the experiment could not consistently reproduce the phenomenon, approximately one success in 30 trials, and free-floating spheres were not observed, it provided one of the strongest laboratory demonstrations of this mechanism. The dirt cloud model suggests ball lightning is essentially a kind of natural fuel-rich fireball, a transient aerosol of glowing silicon combustion. The Chinese 2012 observation strongly backs this idea. The ball lightning appeared right after a ground strike and contained silicon and iron, just as this theory predicts. Many researchers consider this oxidizing nanoparticle theory a frontrunner, as it ties a known trigger, lightning hitting soil, to a physical process that can produce a self-sustaining light-emitting ball. However, it might not explain cases where ball lightning occurs high in the air or enters airplanes, since those are far from soil. This implies multiple mechanisms might exist, or that vaporized material can sometimes be lifted into the air. Another leading hypothesis posits that ball lightning is fundamentally an electromagnetic phenomenon, a sort of spherical electromagnetic resonance or standing plasma wave. The most modern incarnation of this idea is the relativistic microwave cavity theory, proposed by H.C. Wu and others in 2016. In this model, a lightning strike can produce an intense pulse of microwave radiation, high-frequency electromagnetic waves, by accelerating a bunch of electrons to relativistic, near-light speeds in the lightning channel. These microwaves, in turn, become trapped in a small region of ionized air, effectively inflating it like a balloon. The radiation pressure pushes the ionized air outward into a spherical plasma bubble, within which the microwaves keep bouncing, continually ionizing more air and keeping the glow alive. Thus, the ball of lightning is essentially a bubble of plasma lit from within by microwaves that are trapped inside it, a bit like a microwave oven creating a glowing ball in mid-air. This theory is very appealing because it explains several oddities. Microwaves can penetrate glass windows, which is why ball lightning can go through a closed window pane without needing an opening. Microwaves interacting with the inner ear can produce a buzzing or hissing sound. People indeed report a buzzing noise. The plasma ball would naturally smell of ozone and nitrogen oxides from air ionization, matching reports. And critically, this theory explains aircraft encounters. Normally, a plane's metal body would keep external electricity out, but electrons small enough to slip through minute gaps could enter. Once inside, those electrons generate microwaves in the cabin, spawning a ball lightning inside the plane, exactly as in Jenison's 1963 flight. The microwave bubble model also yields the right ball size and lifetime. The dimensions of the electron bunch correspond to balls of tens of centimeters, and the energy trapped would dissipate in a few seconds unless released suddenly, which could cause the ball to explode. While this theory still needs experimental verification, it's backed by simulations, it is considered one of the most comprehensive explanations to date. In fact, it builds on older ideas. As far back as the 1950s, notable physicist Piotr Kapitsa hypothesized that ball lightning might be a standing electromagnetic wave in a plasma, like a self-confined radio wave. The modern microwave theory essentially refines that with lightning-produced microwaves and has better quantitative support. Research is ongoing to reproduce this effect. If scientists can create a miniature ball lightning in the lab using microwave pulses and lightning-like discharges, it would strongly support Wu's model. Some theories focus on the structure of the plasma in ball lightning. For example, Russian scientist Igor Stakhanov in the 1980s suggested ball lightning is a kind of spinning plasmoid, a toroidal, donut-shaped vortex of plasma that somehow stabilizes into a sphere. Others have proposed the fractal structure of charged particles. In 1987, USSR researcher Boris Smirnov put forward a fractal aerogel model, envisioning the ball as a lightweight, mesh-like tangle of fine filaments or particles that slowly recombine. This could explain the semi-solid appearance some report, like a cellular or honeycomb interior structure that was noted by a witness in one case. Another idea by Mikhail Telikin in 2006 involved plasma superconductivity, an exotic state where the ball's electrons move in sync without resistance. While intriguing, these theories are more abstract and harder to test. A more classical approach is electrochemical. A 2010 theory by August Missen posits that ball lightning is sustained by oscillations of electrons in a thin plasma shell, which suck in charged air particles to replenish itself. In Missen's picture, if the ambient charge is too low, the ball simply fades silently. If too high, it can erupt violently, matching the observed range from quiet disappearances to loud explosions. These oscillation models basically treat ball lightning as a self-organizing electrical structure in the air. They are promising in explaining the longevity and extinction behavior, but they require more mathematical development and experimental support. A very recent theoretical development comes from the world of quantum physics. In 2018, physicists created a stable configuration of magnetic fields in a lab, a Shenkar's fermion, which is essentially a knotted ball of magnetic field lines in a quantum gas. Remarkably, the magnetic structure of this fermion matched the theoretical electromagnetic field configuration of a ball lightning. In other words, ball lightning might be what happens when the electromagnetic field ties itself into a knot and traps energy inside. The fermion experiment was done in a Bose-Einstein condensate, ultra-cold atoms, and was a synthetic analog, not a literal ball of fire, but it demonstrated that electromagnetic knots can be stable. This lends credence to older proposals that ball lightning is a kind of topological soliton, a self-stable knotted field. If such knots occur in the plasma created by lightning, they could confine the energy for a time. This is a very cutting-edge angle and still theoretical, but it represents a marriage of plasma physics and topology to address the puzzle. Some have hailed it as a possible solution to how ball lightning can last so long without dissipating at once. It remains to connect this quantum simulation to real thunderstorms. That is a work in progress. Not all ball lightning sightings necessarily involve a physical object. Some might be optical illusions induced by lightning's intense electromagnetic fields. A 2010 study by Josef Peer and Alexander Kendall suggested that the strong magnetic field charges during multiple lightning strokes could stimulate the human visual cortex or retina, causing people to literally see glowing shapes that aren't really there. In laboratory tests, rapidly changing magnetic fields via transcranial magnetic stimulation have made subjects perceive blobs of light in their vision. Peer and Kendall argued that up to half of all ball lightning reports might be hallucinations of this sort. This could explain why some observers see ball lightning only briefly or without any physical damage done. However, many scientists remain unconvinced that hallucinations account for the majority of cases. As chemist John Abramson pointed out, induced force fields, magnetically triggered visual illusions, tend to be simple white or grey shapes, whereas actual ball lightning is reported with rich colors like orange, blue or green. Moreover, multiple witnesses often see the same ball lightning from different angles. It would be exceedingly coincidental for separate brains to hallucinate the same thing in unison. Many encounters also include physical effects like burns, sounds, smells, and electrical disruptions, which a mere hallucination cannot produce. For example, a hallucination would not blow out a window or fuse electrical circuits, yet ball lightning has done so. The consensus is that while some sightings, especially distant or extremely brief flashes, might be misperception or brain-induced illusions, a large fraction of ball lightning events have a genuine physical reality. In other words, the hallucination hypothesis might trim away a few dubious reports, but it does not solve the core mystery of the authentic fireballs that have left scorch marks and shocked witnesses. The strangeness of ball lightning has invited some truly far-out speculation in the past. In the 1960s and 70s, a few scientists wondered if ball lightning could be powered by nuclear energy, for instance a miniature fusion reaction in air or a natural nuclear battery of some sort. There was even a suggestion of a ball lightning vortex reactor in the atmosphere, though no evidence ever supported this. Another hypothesis posited that antimatter from space might annihilate in the atmosphere and produce glowing spheres, but this was deemed highly implausible given the frequency of ball lightning versus the rarity of antimatter droplets. Perhaps the most exotic was the notion that ball lightning could be a micro black hole left over from the Big Bang that entered the atmosphere and ionized the air as it passed. This idea, proposed by some in the 1970s, has not been taken seriously, for such micro black holes would likely behave very differently, and thankfully none are zipping through thunderstorms. Yet, listing these extremes is useful to illustrate how open the question remained throughout the 20th century. Scientists were literally checking every corner of physics for answers. Today, most of these exotic ideas have fallen by the wayside as more conventional electrical or plasma explanations gain experimental support. In evaluating all these theories, the scientific community leans toward those that best match the accumulated evidence. The chemical plasma model, burning silicon, and the electromagnetic cavity model, microwave bubble, are currently seen as highly promising, and they might even be two facets of one larger explanation. Perhaps lightning sometimes produces a hot chemical fireball and other times an electromagnetic plasma bubble, or sometimes a mixture of both. As noted earlier, it's conceivable that multiple types of ball lightning exist. Some events might be more electrical in nature, others more chemical, which could explain the wide variation in color, behavior, and apparent solidity reported. Modern lightning research networks have even tried correlating reported ball lightning events with lightning strike data. In one study conducted between 1994 and 2016 in Central Europe, about half of ball lightning occurrences were associated with nearby cloud-to-ground strikes and half with distant or intra-cloud lightning. Intriguingly, many associated strikes were positively charged lightning, which is relatively rare. This hints that unusual lightning conditions might be a factor in forming these orbs. In conclusion, ball lightning has evolved from folklore into a serious scientific puzzle spanning multiple disciplines. Historical reports established it as a real phenomenon, modern encounters provided measurements and clues, and now a combination of electrical engineering, plasma physics, and atmospheric chemistry is being brought to bear on the mystery. The fragmented science of ball lightning, so called because of its interdisciplinary nature, is gradually coalescing as more data emerges. While no definitive eureka moment has occurred yet, the community agrees that the mystery is closer than ever to being solved. Ball lightning may soon be demystified as a peculiar but explainable side effect of lightning and plasma physics, a once mythical fireball finally captured by the laws of science. Until then, it remains one of the most fascinating and literally illuminating phenomena one can witness when nature's fury and wonder intersect. Thank you for watching. If you enjoyed this video, feel free to like, subscribe, and share it with fellow explorers of our baffling world.